Hi there, this is Lachelle Foley. Welcome to The Witch's Tech. This video is going to be about basic infrastructure, so the networking and hardware that you will need in order to do this thing. This will be part of a new playlist, Building a Home Cloud, and that will take you through step by step how to reproduce the tech that we have here. I'll assume that you're starting from something pretty similar to an average home setup. And I'm going to assume that you have very little technical knowledge of this sort because even most people who get a degree in computer science really don't get a lot of exposure to this side of computing. In this video, the point is to think about the things you want to plan before you even start. Even before you decide whether you're gonna start, you want to think about these things. Specifically, the networking services and hardware that you will need, and the computing hardware that you will need. In this video, we're just talking about gathering components and a little information related to that. Instructions for what to do with them will come in later videos. So the obligatory pitch. Please like the video. I always forget to like. I feel so bad about that. Anyway, please like the video. Please don't forget. And if you like this content, subscribe. If you would like, we are a 501c3 nonprofit organization, so you could donate to AthensAreaPagans.org/donate or use the QR code. If you would just like to learn more about us, AthensAreaPagans.org or use the other QR code. I do want to start with a warning. This is dangerous. You can get hacked. I don't have perfect knowledge and no one does. Like, I'm going to try to steer you in the right direction so that you don't do something that's going to like mess up what your world, your life, your house. But no one, like if someone could, there wouldn't be all these data breaches, right? Like really smart people have trouble and that's just the way it is. So you got to understand the risks. And if you want to think about the risks, like, okay, you've got a house. And what you're doing is the equivalent of cutting a door into one of the rooms of your house, and that door goes out to the outside world, and that door never ever locks. So 24 hours a day, 365 and a quarter days out of the year, that door is unlocked, and anyone can walk in through that door. You're going to want to be real careful how the room that door attaches to relates to the rest of your house. Really, really important that you think about this and that you understand that if someone got through that door and into the rest of your house, they may do things that you don't want. And of course, the house here is just the rest of your network, all of your devices, your cell phone, your car, etc. So think carefully before you decide to do this. I do want to spend a little time talking about Archimate and Archi. So Archimate is a diagramming tool or a diagramming specification that I use a lot. So the sorts of things that I have to think about and the sorts of things that I have to communicate, they're sort of easy to do if I use this diagramming tool. If you'd like to learn more about Archimate, use the QR code next to the word Archimate. I use the Archi software and use the QR code next to the Archi word if you want to see the software that I use to build these diagrams. The two diagrams that you see right now, I don't want you to like parse them at the moment. We'll talk about them in a bit. But the top diagram is what your home tech probably looks like right now. And the bottom is what it needs to become. And you can see there's quite a lot of difference between those two. So next up, a little Archimate overview. And for this overview, I've chosen to use a library because most people have been to a library and they know what libraries do and what they look like. So it seemed like that would be a good thing to do. So each element, node, figure, I might use any of those words. I might say box. And the things that are connected by lines and arrows, those things, the elements, the nodes, figures, each one of them has a meaning. So the color has a meaning and the icon in the box or element has meaning. Also, each of the connectors has meanings. The color of the connector and the shape of the connector has meanings, whether it's dashed or not, has meanings. And I don't expect you to memorize all of this. I will lead you through these things well enough, but I want you to be sort of comfortable with them. So what I've circled right here in the pink has the library. The library I'm calling a business product in this case. The library realizes or causes to exist. Those arrows with the sort of light-colored triangular endings, those arrows mean realizes, causes to exist. So the library causes to exist two services: knowledge dissemination and meeting spaces. And that's two things that most libraries do. Note that both of those are services: knowledge dissemination and meeting spaces. Each figure can take on two forms. You can either have, sort of a square or something like a square with an icon in the upper right-hand corner. So if you look at the upper right-hand corner of knowledge dissemination, you will see a little capsule-shaped object, and that is more or less the same shape that is around the words meeting spaces. So both of those mean a service. The yellow means business, so both of those are business services. Showing you another example of two different views for the same figure. Librarians, I've chosen a rectangle with the icon in the upper right-hand corner. Book borrowers, however, I have decided to emphasize that this is a business actor. So this person, the little shape of a person, means an actor, business actor. An actor is just any entity that can do something or have a behavior. So it could be another business, it could be your chatbot, whatever. And it's kind of hard to fit book borrower into the little head of the icon. So a lot of times the label will be off to the side or above or below or something like that. Am I going to be able to do this? Okay, so my computer is occasionally slowing down, and I'm trying to figure out what is taking all of this stuff, all of the electrons. Anyway, moving along. Here, I have chosen to emphasize a serving relationship. So the librarian serves the library, and the library serves the book borrower. And you can, that arrow, the sort of open-ended arrow and the plain line, that means serving. That's a serving relationship. And eventually, I will be allowed, no, to put my, I may have to re-record this. Okay, I don't want to re-record it. Behave, computer, behave. I'm trying to decide. So like OBS is using 2.7 gigabytes. Like, I don't know. Anyway, okay. Anyway, continuing the Archimate overview, I want to introduce three new node types. So a business product, that's the library. And I could have called it something else. Could have called it a resource or a location. I called it a business product here. A technical object, a business object. The business objects are meeting areas and bookshelves. So libraries have meeting areas and bookshelves, and those are business objects. They are not products. Your library doesn't sell these things, but it uses them. The connector between bookshelves and meeting spaces and library, that connector means is composed of. So the library is composed of bookshelves and meeting spaces. So the closed diamond head is what means composed of. If you look at books, books are aggregated. So the light-colored diamond head means aggregated. So libraries aggregate books. And books are technological artifacts. So that means they are a data object. A book is a data object, has data in it. It's not the product. The library doesn't sell the books, but the library uses the books in its other business operations. So a technological artifact is a data object that is used in the other operations of the business. And I chose to say that the library aggregates books rather than is composed of them, because if you walk into a library and you see a bunch of shelves that have labels on the ends, and you see tables with chairs and maybe a couch and a reference area and maybe some computers, you pretty much know that this is a library, because that's what a library looks like. Conversely, if you walk in to a room and it's just got stacks of books in it, that's not a library. It's just a storage room with books, right? Books in a library are arranged to make the knowledge dissemination easy, and you're given places where you can read. Anyhow, these are just some new node shapes to tell you about. I should say I'm abusing Archimate a little bit by using this for a library. On the other hand, a library is sort of the original information technology, and information technology is what Archimate is made for. Archimate is surprisingly adaptable despite really being made for IT. Here, I would like to point out that you can have things work together. So here, meeting rooms, which is a component of a library, works together with the library to realize, both of those together, realize the meeting spaces. And it could mean that they're working together. It could also mean that sometimes the library will realize that some of the meeting spaces are not in meeting rooms. It's possible. That's what that means. A couple of notes. An architectural view is always only a piece of the whole. You're never going to see everything, or it's impossible to read. And you're only going to see a tiny piece of Archimate in these videos at all, because it's just huge. It does lots and lots and lots of things. In this, we are seeing lots of yellow. That's the business layer. But most of the videos, because of what we're doing, are going to be green, the technology layer. So now I want to move on to what you probably have right now in your house. You probably have an internet service provider, and that internet service provider has brought some sort of box, your cable modem perhaps, to your house. And that box brings the internet into your house, and and that's the ISP receiver. So your ISP is the business actor in the yellow box, and it has, brought you an ISP receiver. That's the box in your house, and it serves your home. It's actually assigned to your home, or your home is assigned to it. And I've set your home as a location in this case. The box serves your Wi-Fi access. That's how you get your wireless access at home. And it also serves your home devices. So all of the devices, the car, your laptop, your tablet, your phone, the smart doorbell, whatever else you got, all of those are there. If you happen to have wired access and it's not just Wi-Fi, just hold that thought. You're already ahead of the game. This part is kind of outside your house in a way, but it's important. And you'll see why it's important very soon. Your ISP provides a receiver, and it assigns you a dynamic IP address. So between the receiver and the IP address, those two things kind of work together to realize your internet access. So the box plus the IP address both go together and give you internet access. But your internet access is dynamically addressed. So that means that every so often your IP address changes. Your IP address is kind of like a phone number. If you imagine that your phone number suddenly changed every couple of weeks or every couple of months, it would be hard for people to call you, right? So the first thing we're going to have to do is change that. But let us move on. Okay, this diagram's a little more complicated, obviously. This is what you need to have. So we're going to walk through this diagram in sections. First, I'm going to gray out all of the stuff that you've already got. So there, those things are grayed out. And I would like to emphasize what needs to change. So if you look at the pink outline, it now says static IP address and statically addressed internet access. So that's one of the things we're going to have to get. And right now, we're going to look at that and the other parts of the external network. So the network that's primarily outside of your house. What is it that you're going to need to happen? So before we get there, though, I want to go through sort of what happens whenever you whenever you go visit something on the internet. And this is not like I have left some things out to make this easier, and there's probably some order of operations that happens in a slightly different way than what I've shown here, but this will give you the gist. This is basically what's happening. Also, I am totally abusing Archimate right now, so this is the equivalent of using a kitchen knife as a screwdriver. Yeah, you can do it and it works, but it's maybe not ideal. Okay. Archimate was the tool under my fingertips, like a kitchen knife might be the tool under yours when you need a screwdriver. Well, okay, I just used Archimate for this. I think it will get the idea across pretty well. So first, we have a business actor, a person, let's say that's you, and you have a motivation. So that purple, the little purple thing, that means motivation. Purple means motivation, and the little target means goal. So your goal is to check out the AAP website, right? And so you enter into the URL bar in your browser, AthensAreaPagans.org. And that triggers, so the arrow going from that enters the thing over to your web browser, triggers your web browser to do some things. And the very first thing that your web browser does is it goes to the domain name service and says, hey, I need the IP address for AthensAreaPagans.org. And the domain name server responds with, oh, yeah, sure, that's 47.48.249.26. And this is not a secret. You probably don't usually see it, but your browser has to know it or you can't go to that website. So anyway, that's the first thing that happens. And then your browser says, oh, cool. And your browser contacts the IP address, 47.48.249.26, and it says, hey, give me AthensAreaPagans.org. And the thing that answers at that IP address says, oh, here is some encryption information and the name of my certificate authority. And your web browser says, oh, okay, fine. And it takes the encryption information and sends it to the certificate authority, and the certificate authority hopefully says, oh, everything looks good, and sends that information back to your web browser, and then your web browser sends an encrypted request to 47.48.249.26. I think I probably got that right. Anyway, sends an encrypted request, and then encrypted, it gets back the website for AthensAreaPagans.org. And then finally, your web browser displays to you, realizing the goal, I guess, or at least realizing the website, and you can check out the Athens Area Pagans website. So to sort of pull that back into what we're doing right now, these purple outline boxes, the thing that answers at the IP address, that's what you're building inside your house. So you're putting that in your house. And the stuff that's in the orange, outlined in orange, that's the stuff you got to get from somebody else. So let's talk about all of that. First, the static IP address. So this is how others on the internet find you, of course. You're probably going to get it from your ISP. In the US, in most places in the US, it may not be exactly this, but usually you get if you need a static IP address, you go to your internet service provider and you say, I need a static IP address. If that's not how you're supposed to do it, then they at least know how, and they should be able to tell you this is where you need to go to get one. In the US, the cost, you're going to expect anywhere between $5 to $50 per month for a static IP address. So, this is one of the things to keep in mind if you're going to do this. It costs some money. It's not super expensive, but it's not cheap. When you're doing that, be creative. Like try different ISPs if you have multiple in your area and see if one of them is cheaper overall between internet service and having a static IP address. Or, think a little outside of the box. I have the business tier of access from my internet service provider because getting the business tier was actually cheaper than trying to get the home plus the IP address. And, on top of that, I got extra stuff like 24/7 tech support because it's the business tier. It was kind of a good deal all the way around. Just, keep in mind alternate ways to make these things happen. Next, you're going to need domain name service. So you need a domain name, and it needs to be advertised to the domain name servers so that people know how to get the IP address and then get to your website. There are many domain registrars. Two examples that you might have heard of are GoDaddy, very famous one probably, and Google Domains, and there are lots of other ones. You're probably going to spend $10 to $30 per year on a domain registration. Do not let it expire. Even if you think, I'm not going to use this for a couple of years, I'll just come back. No, because they're going to want to charge you $2,000 or $20,000 or something absolutely ridiculous to get your IP, your domain name back. So don't let it expire if you think you're ever going to want it again. You do only need like the two parts, the top level and the second level. So in the example.com, the com part is the top level and the example part is the second level. You need those two parts. If you want to add anything on, sort of the left side of example.com, like, kittenpics.example.com or chat.example.com, most of the time you can get as many of those as you want. They're for free. You just sort of add them on to your domain name. You are going to need a certificate authority. This is free. We're going to use Let's Encrypt, and they are free. There are paid in certificate authority services, and they may be easier to use or something, but we're going to use the one that's free. You don't actually have to do anything about this now. When we get to the point where we need it, we'll talk about that then. Just letting you know that that's a thing that will have to happen. You also want to think about your network capacity. So how many bits can you push up the wire or pull down the wire? In the box there, you see what my internet capacity was at the moment that I think I asked Firefox to measure it for me. And you notice there are two numbers. One of them is download and one of them is upload. So 361 megabits per second download and 10.7 megabits per second upload. Normally, you are doing a lot more downloading than uploading. You make a request and the website sends you pictures and videos or what have you. But if you're doing the service, if you are the service, then the upload begins to make a lot more difference to you. And that's going to limit what you can do from home. So, that upload is going to matter. So you probably would be able to support maybe a couple of people doing like a Zoom type call or some voice over IP, but not a lot of this. And you're definitely not going to become Netflix at home, right? And now let's talk a little bit about the internal network hardware. First thing to keep in mind, or the first thing to think of, is you need gigabit networking. Pretty much any computer, any switch, any router that you buy, unless you're going out of your way for something else, is going to be at least a gigabit. So that means that you can, like the numbers before that said 361, it would say at least 1,000. So it's 1,000 or better, gigabit networking. If you're going to be getting computers from your friends or from a place like Free IT Athens or out of your closet, it might not be gigabit. If it's sufficiently old, it could be 100 base T, which used to be called fast internet. So you need gigabit. So the reason that you need gigabit is you need the computers in your house, when they talk to each other, that needs to be faster than the upload or the download. So you want the limiting factor to be this upload or download. You don't want it to be the speed at which your computers can talk to each other. So you want gigabit networking inside your house, even though you don't quite get gigabit networking up and down the wire from your ISP. Your router. There's a picture of my router and some diagrams about the router. The router can be part of your ISP receiver. It costs you less. You don't have to buy a router, but they are going to control the router. Anytime you want to make a change, you're going to call them up and say, hey, will you open port blubbity blubs? And, usually they'll do it. They're pretty good about that. But if for whatever reason things aren't working out and you need to do it yourself, or you're a control freak or you just like it, you can buy your own router and it costs a little bit of money, but you have control and maybe you learn a little bit more about how things work. It's okay if that router also does your Wi-Fi. The cost is $30 to $200 and you can spend just as much as you want to, but typically a router that's in the range of $50 to $100 is probably good enough for what you need here. One thing that it has to have is port level NAT. NAT is network address translation, and you need port level NAT. Make sure that you have that. Most of the modern routers, if they have NAT at all for security reasons, it's port level NAT, but make sure. Switches. You're going to need switches. Those are what allow your computers to talk to each other. And each switch will have a number of ports, so you can see cables coming out of the back of the switch in the picture there. Again, make sure that it's a gigabit switch. It doesn't have to be managed, plain boring switch, but it needs to be a gigabit. The number of ports is the number of computers plus one. So the plus one is the router. You need a wire coming from the router to the switch, and then you need wires going out to each of your computers. However many computers plus one, that's how many ports you need. The cost is going to be between $10 and $100, and again, you can spend as much as you want to, but something in the $30 range, maybe $20, $30 range. Depending on how many computers you have, if you need a 30 port switch, you may actually go over 100, but probably not. Anyway, if you've already got a gigabit switch and it's not quite big enough and you just want to get another small one, you can chain them, not a problem. Just do not make a loop. Networks have to be trees. Do not make a circle. Everything will stop working. Cables. This is the wires in the wired networker. If you are buying cables, Cat 6 is fine. So category 6 Ethernet cables is fine. If you have Cat 5 cables, if you have Cat 5 cables laying around, that's fine. Use them. They'll be perfectly fine for what you're going to be doing here. But if you're going to go out and buy, Cat 6 is probably what you're going to find. And at this point, I looked on Amazon. Cat 5 was actually more expensive because it's just harder to find them these days. Cost, $15 to $30 should get you maybe 6 or so 6-foot cables, Of course, if you have more computers or a longer distance, then the cost goes up, right? If you need to put your computer somewhere far away from your router, we'll talk about that in a minute. Okay, so this part, and we're getting close to the end of this particular video, is we're going to talk about the actual computers. Okay, before we get too far into that, an aside about virtual machines. If you don't know what virtual machines are, don't worry about it. This is only for you if you know what virtual machines are. You can do all of this with a virtual machine. If you're going to do that, I recommend that the host machine for the virtual machines be not any important machine to you, like a separate machine, right? You can do all of this with virtual machines, but you're going to be on your own. I know how to do it, but I've got other stuff to talk about here, right? I'm going to assume for all of these videos that you're running on Metal. And very importantly, all of the computers that are going to be part of your home cloud, this home networking, they need to be sole purpose computers. Do not use your personal computer for anything having to do with providing an internet service. Just don't do that. The computers that you use in the swarm need to be only for the swarm. They don't do anything else. Remember I said security, and this is bottom level of it. Just make them separate. In terms of the number of computers, if you're just trying to figure out, oh, can I make this work, and you just want to see how this thing works, you can scrape by with 3 computers. 6 is better. So let's look at the diagram there. There's a Docker swarm, the sort of long bar at the sort of bottom on the left. Docker swarm is composed of, and you'll see on one side it says the Docker manager or manager nodes could also be workers, and there's a 3+. That means you have to have at least 3 manager nodes in order for Docker Swarm to work. If you don't have 3, it won't even start up. You get nothing. So you need 3 computers. All 3 of them have to be a manager node, and at least some of them have to be worker nodes, or no work will be performed, but you can manage lots of stuff. We'll talk more about what manager and worker means later. You can have more computers. Specifically, I recommend at least 1 more worker node, that's just a worker, but could be promoted to manager if you needed one. A file server, so that's the thing that's going to just serve files to all the other computers. And a backup machine, and the backup machine just makes backups of all of the data that's important, right, that you need to keep. So that makes 6 computers, the 3 manager nodes and an extra worker and a file server and a backup machine. So 6 computers is what I recommend. Another thing is if you make your file server and your backup server sort of swarm ready, give them all the stuff they need. And so if like you lose two of your main machines, you can take one of those and pull it into the swarm, at least temporarily, and have things back up again. So I kind of recommend that. 6 computers is good. We'll, of course, talk more about that in detail in later videos. The computers themselves don't need to be fancy. We're not trying to be Zoom, Netflix, Spotify, AWS. I mean, we're just not going to be able to do that. Even if you've got the computers for it, you're limited by that upload speed. You can definitely host a website. You could host chat, something like Matrix, even when people uploading and downloading, videos and pictures. That's not a problem. Nextcloud, something like that, no problem at all. You might get into trouble if you try to use their documents. Like they've got a sort of a thing like Google Docs, sort of, where you can make documents online. That can be kind of slow, or at least it was slow the last time I tried it, although it might be better now. Anyway, you want at least 4 gigabytes of RAM. Multi-core is good, but the speed of the CPU is not critical. One thing I do recommend is that you use a solid-state drive for the operating system. So just faster. So all of the stuff that the computer has to do to be a computer and all of the stuff that Docker has to do to be Docker, that will happen much more quickly because the read, the I/O from the solid-state drive is just faster than a regular hard drive that spins. The computers need to support virtualization, and that's something that you'll have to determine at the BIOS level. So you'll set that in BIOS, which is the thing that happens before the computer ever boots up. Make sure that you do support virtualization. The machines are going to run headless, so that means that they don't need a keyboard, mouse, or monitor. But you need to have a keyboard, mouse, or monitor because if one of the computers stops working, you want to be able to hook the keyboard, mouse, and monitor up to the computer to figure out what happened to go wrong. An old monitor is fine because hopefully you're not going to use this very often. I would say have your keyboard and mouse be wired because some BIOSes just will not play with wireless. So just go ahead and have a wired mouse and monitor. It's easier. And like I said, you don't need it often. So it doesn't need to be fancy or ergonomic or something. Just something that you can set down. Maybe not even very big, just so you can get your work done. I want to talk for a minute about a jump host. So most of you should not have a jump host. Jump host allows connections from the outside world. So that means out in the internet with all of the hackers, you're letting the internet connect into your house, into your network. You don't want that to happen unless you have to have it happen. And if you have to have it happen, you want to be very, very careful about how you do it. I'll get a little bit into the how to be careful, but only if you know what you're doing should you have a jump host. You should probably not have a jump host unless you need it and you know why. This is dangerous. This is another one of those security things, right? You don't want to put a big hole between that outside room and the rest of your house. If you are going to have a jump host because you need it for whatever reason, make it completely separate from the swarm. Just totally separate from the swarm. Make sure that you are only connecting in using passwordless SSH or something of a similar security. And make sure that the jump host does not have passwordless SSH to your swarm. Because if someone does get into the jump host and does have control over this machine, you don't want them to have really easy access over to your swarm, right? If you have this sort of passwordless SSH, you usually have easy access. You could have it and just get you can also put a password on your passwordless SSH, or you're using the key pairs. If you're using key pairs, that's great. Make sure the password's really strong. Just make sure it's hard. Once they get to the jump host, it's going to take work to get to any other computers anywhere else in your house. And if all of that sounded like wah, 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 you do not need a jump host. Okay, very important now is to plan where everything goes. In fact, you want to do this first, really. I mean, it's a lot of stuff, right? You got 6 computers plus a keyboard, mouse, a monitor. You've got switches, you got cables, you got power supplies. That's some, that's a footprint, right? So really think about where you're going to put everything. You got space for it. If you cannot the best place is put it near your router, near the box from the ISP. If you cannot do that, then there are two options that I can think of. One is take a solid Cat 6 cable and run it like either through the ceiling or under the carpet or tap it to the wall or something. Make sure that it's not going to be bent very much, because the solid cable is not good for being bendy, but solid cable is good for making distance, right? So you want a solid Cat 6 cable and run that wherever it needs to go, but try to make sure it doesn't bend very much. And most of the cables that you get are stranded just for everyday use. Anyway, the other option is something called Ethernet over Power, and I use that in the house to, get to other parts of the network. That works okay. I mean, actually, it works really well, but every so often, like once a year, it's going to have a bad hair day and it just stops working. You have to go unplug everything and push buttons and what have you, and then it'll work again for another year. And once in a while, they just die. One of them just stops working and you got to get a new one. A Cat 6 cable is just going to work. So if you can do the Cat 6 cable, that's probably the better option. If you can't, that's just not reasonable, then Power over Ethernet is an option for you. And honestly, I think the cost is going to be about the same, depending on how long the Cat 6 cable needs to be. Oh. Finally. Okay. I don't know what happened. All right. So, in summary, a little checklist, and this is in the order that I would probably do it, but you do it in whatever order makes you happy. I would figure out where everything's going to go first, because if there's no room for it, I mean, there's no point in trying if you got no place to put it. Then go figure out what it's going to take to get a static IP address, because that's one of your big ticket items. It's going to be one of the more expensive parts of it. And figuring out the routing, because if you need to have your own router, that can also be expensive. And you may not know ahead of time until you get the static IP address and you actually try to work with your ISP. You might not know whether or not you actually need your own router. So think about ahead of time. If I have to spend 50, 60 bucks on a router, is that going to be okay? Whoops, sorry. Let me do that. Get your, set up the routing, register your domain name, extend your networking. Like if you can't put your computers near the router, do that. Obtain the computers and the switches and the cabling and all of that stuff, and then stage all the hardware. Just sort of put it where it needs to go and make sure that it all hooks up. You got power, you've got enough space to get to the power outlets or whatever. Stage everything, make sure it's ready, and that will get you ready for the next videos. And in fact, you really don't even have to do all of that. Like, the next video is just going to be about the networking, so you don't necessarily have the computers. You don't have to have all of the computers for the next video. The one after that, we'll talk about what to do with computers. There's the upcoming next two videos. And, okay, today's rubber ducky. I don't know how long I'll be able to keep this up, this rubber ducky per video, but voxel duck, really? Yeah, voxel duck. So, when you're looking at something up close, especially if it's a digital picture, it gets kind of pixelized, and if you look up real close, you can't really see how everything's going to go together, but it does. Anyway, hope to see you soon.